Hello everybody, welcome to Easy Science. இந்த சேனல் பிடிச்சிருந்தா லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணுங்க, பெல் ஐகானை கிளிக் பண்ணுங்க. அப்போதான் புதுசா போடுற வீடியோஸோட நோட்டிபிகேஷன் உங்களுக்கு வந்து சேரும். Good morning. Today we are going to see part 4 of the topic laws of motion. Today we are going to see the topic mass and weight. What are the difference between mass and weight? The mass, it is a quantity of matter contained in the body. Weight, it is the gravitational force exerted on it due to the Earth's gravity. The unit of mass is kilogram and the unit of weight is Newton. Mass is a scalar quantity and weight is a vector quantity. Scalar means one which has magnitude and known direction. Vector means one which has both magnitude and direction. Acceleration due to gravity. Acceleration due to gravity on the surface of the earth is 9.8 meters second minus 2, and the acceleration due to gravity on the surface of the moon is 1.625 meters second minus 2. So if a person whose mass is 60 kg stands on the surface of the earth, his weight would be 588 Newton. It is according to the formula W is equal to M into G. W is the weight of the person and M is a mass and G is acceleration due to gravity. 60 is the weight of the person on the surface of the earth into 9.8, which is acceleration due to gravity on the surface of the earth, which is equal to 588 Newton. If the same person goes to the surface of the moon, he would weigh only 97.5 Newton. Here 60 stands for weight of the person into 1.625, which is acceleration due to gravity on the surface of the moon, which is equal to 97.5 Newton. Next one is apparent weight. What is apparent weight? The weight that you feel to possess during up and down motion is not the same as your actual weight. So when you go in a lift, you can experience this up and down motion. The apparent weight is the weight of the body acquired due to the action of gravity and other external forces acting on the body. Let us consider a person of mass m who is traveling in a lift. The actual weight of the person is W is equal to mg, which is acting vertically downward. The reaction force exerted by the lift surface R taken as apparent weight is acting vertically upwards. So we see here the weight of the person is m into g, mass into acceleration due to gravity, is acting vertically downwards, whereas apparent weight R is acting vertically upwards. Next one, let us see the different possibilities of the apparent weight of R of a person that arise depending upon the motion of the lift upwards or downwards, which are given in the table. So the first case is lift is moving upward with acceleration A. R minus W is equal to F net, which is equal to M into A, or R is equal to W plus MA, or R is equal to MG plus MA. W, you can even write it as MG, and R is equal to M into G plus A. Here R is greater than W. R is apparent weight and W is the actual weight. So apparent weight is greater than that of actual weight. Lift is moving downward with an acceleration A in the second case. So W minus R is equal to F net, which is equal to MA. R is equal to W minus MA. R is equal to MG minus MA. R is equal to M into G minus A. Or R is lesser than W. Apparent weight is lesser than that of the actual weight. Next, lift is at rest. Here the acceleration is 0. A is equal to 0. R is equal to W. R is equal to MG. Here R is equal to W, where the apparent weight is equal to the actual weight. The next case, lift is falling down freely. Here the acceleration is equal to G. A is equal to G. R is equal to M into G minus G. R is equal to 0. Apparent weight is equal to 0. This case. Next one is weightlessness. So when you go to an amusement park, you may go in a roller coaster or on a giant wheel. When you go there, you experience a free fall. That you call it as weightlessness. So when the person in a lift moves down with an acceleration A equal to acceleration due to gravity, that is A is equal to G, this motion is called as free fall. Here the apparent weight R is equal to M into G minus G is equal to 0 of a person is 0. This condition or state refers to the state of weightlessness. Next one is weightlessness of astronauts. Astronauts are not floating but falling freely around the Earth due to their huge orbital velocity. Since space station and astronauts have equal acceleration, they are under free fall condition where R is equal to 0. Here, both the astronauts and the space station are in the state of weightlessness. They seem to be floating, but they are not floating. There seem to be no gravity, but it's not like that. There is little amount of gravity there in space. Application of Newton's law of gravitation. Dimensions of heavenly bodies can be measured using gravitation law. So the radius of the earth, the mass of the earth, acceleration due to gravity, everything can be calculated with higher accuracy. It helps in discovering new stars and planets. One of the irregularities in the motion of the stars is called wobble and lead to disturbance in the motion of the planet nearby. In this condition, the mass of the star can be calculated using the law of gravitation. It helps to explain termination of routes is due to the property of geotropism, which is the property of route responding to the gravity. And it helps to predict the path of astronomical bodies. Thank you. Here ends the first lesson, the laws of motion.